Welcome to Lesson 2-4, Laws of Exponents. Today we're going to talk about the laws of exponents and how to use those laws of exponents to simplify problems. Alright, so in order to understand these laws of exponents, we have to actually understand what's going on. So what we're going to do for each problem is we're going to look at what's actually happening, and then we're going to look at how we can make it simpler to do. So in this case, when I have 3 to the third power times 3 to the fourth power, if I break down 3 to the third power into standard form and 3 to the fourth power into standard form, I know that I get 3 times 3 times 3, and then I get 3 times 3 times 3 times 3. And then I'm multiplying both of these together. Well, now that you see it in its standard form, you notice that we have all 3's and that now we have 7 of them that we're trying to multiply together. And I know from my understanding of math that I can just take that 3 and make it my base and say that since I'm multiplying it together 7 times, that I can shorten it by calling it 3 to the 7th power. Well, if you take a look at the exponents, is there any way that you can use 3 and 4 and get to 7? If you notice that you could take 3 to the third power times 3 to the fourth power and say that it's equal to 3 to the 3 plus 4 power, you'd be correct. So whenever we're multiplying numbers that are in exponential form and they have the same base, we can add our exponents. Okay, so the product of powers law, so that tells us for any real number a and all integers m and n, if I have a to the m times a to the n, it gives me a to the m plus n. So basically what it boils down to is when multiplying exponential form with the same base, you can add the exponents. And actually, let's put you can keep base and add the exponents. Okay, so now to solve, we would still end up having to do 3 times 3 times 3 times 3 7 times, but when you're just looking to simplify a problem, you're able to use this, and sometimes in simplifying the problem, you'll find that you actually make it a lot easier. So I know that it seems odd to put these together and then have 3 to the 7th and note that it's this big long problem, but when you have more pieces to an expression or an equation, sometimes it is easier to use these laws of exponents and make that problem smaller by making it simpler. And sometimes you'll find out that you end up actually getting rid of some of your pieces. All right, so let's go ahead and try this. So what we're going to do for the first two is we're going to break it down into the kind of how and why, and then give our answer. And then for the bottom two, what we're going to do is we're going to show it using the rule or the law. So in this case, I know n to the fifth power means n times n times n times n. I think I said it 5 times. I know I at least wrote it 5 times. Times, because I know parentheses mean times, n times n times n. And I know that this is 1, 2, 3, 4, 5, 6, 7, 8. So this is n to the 8th power. Here I have k to the 4th power, which is k times k times k times k. And then k to the 1st power means that there's just 1k. So I know I have 1, 2, 3, 4, 5. So this is k to the 5th power. Now here we're just going to use our law. So since both of my bases are the same, which I should have checked up here, so n and n, k and k, since both my bases are the same, I can keep my base and add my exponents. So I know that I would get y to the 12th power. Here, my bases are the same, so I keep my base and I add my exponents. Now in this case, I can multiply these whole numbers because if you break this apart into signs or into using your symbols for operations, you know that because it's multiplication, we can move it around. Okay, according to the commutative property of multiplication, I can move my numbers around. So I can move it around and put like terms together. And I know multiplication is always going to give me the same answer no matter what order. So I can do 8 times a cubed times a squared. I can do that first. So I can multiply my two whole numbers and get 8 and then keep my base and add my exponents. So here I know I should get 8a to the 5th power. And remember, the 3 is only attached to the a, so it does not impact the 2. The only way it would impact the 2 is if this were in parentheses, and that would actually change things a little bit, which we'll look at down the road. All right, so what if I were to take 2 to the 3rd power squared? Well, I know that squared means that I'm taking the number times itself. So when this is your exponent, even though this number has an exponent, this whole thing is still your base. And I know that exponential form means that I take my base times itself, however many times I have as an exponent. So in this case, I'm going to take my base times itself 2 times. So my base is 2 to the 3rd power, and I have to multiply it by itself. So I have my base 2 times, and I multiply those together. Well, I know that from my rules of product of powers, I know that when I'm multiplying two numbers with the same base, I can just add the exponents. And that's what I got to. So I know that this is actually equal to 2 to the 3 plus 3 power, which is equal to 2 to the 6th power. Well, let's see if there's a way to shorten this step and not have to go from here to here to here. Can you see any way to go from what we were given to 2 to the 6th power? If you said multiply by the exponents, you'd be correct. So 2 cubed to the 2nd power is actually equal to 2 to the 3rd times the 2nd, which is equal to 2 to the 6th. And again, here's why. And we could even break this down and put in here that it'd be 2 times 2 times 2 times 2 times 2 times 2 and go through all that again. But as long as you understand why and can show me the examples and reasoning behind it, we're doing fine. So again, the law for this one, for a power of a power, for any real number a and integers m and n, a to the m to the n is equal to a to the m times n. Okay, so again, to break it down, when you have a power to a power, you keep the base and multiply the exponents. All right, so let's try a couple of these. So we have s squared to the 5th power. So I know that this means s squared times s squared times s squared times s squared times s squared, which is equal to s to the 10th power. Here I have 10 to the 3rd times 10 to the 3rd times 10 to the 3rd times 10 to the 3rd, which I know means I can just add all my exponents and get 10 to the 12th. So here, let's put it together and just look at the different pieces. So here I have p to the 4th to the 2nd. So I know that that would mean p to the 4th times the 2, and then q to the 5th times the negative 9. Right? I do not combine these because 5 and 9 are only connected to the q, they're not connected to the p. So in this case, I would have p to the 8th, q to the negative 45th. Right? And then here I have negative 7 to the negative 3rd to the negative 6th, which means it's negative 7 to the negative 3 times the negative 6, which means I have negative 7 to the 18th power, because a negative times a negative gives you a positive. All right, so if you have a power of a product, so if you have two numbers that you're multiplying together and then you're taking that number to a power, what's actually happening here is again, this is your base, and then this is your exponent. So what this means is xy times xy times xy. And I can break it down. The x and the y are only connected to imply that it's multiplication. So I know that that's the same thing as putting multiplication signs in between everything. And then I can rewrite it and have all my x's together, and then have all my y's together. So times y times y times y, which I know breaks down to x to the 3rd times y to the 3rd. So to make this easy, it's the same idea of when you have a power to a power. Just assume that you have x to the 1st power and y to the 1st power. So you're taking that 3 and multiplying it by 1 and 3 and multiplying it by 1 to both of the numbers. So the rule or the law of exponents here is the power of a product for any real numbers a and b and any integer m. A times b to the m is equal to a to the m times b to the m. All right, so let's go ahead and try this. So here, again, we're going to break it down. So I have a times b times a times b, so it's 4 times a times b times a times b. So 1, 2, 3, 4, so a to the 4. 1, 2, 3, 4 times b to the 4. Here I have 4a times 4a, which I know would be 16. Well, and actually let's not even skip to the 16. Let's look at what this would actually mean. This would be 4 squared, because it's 4 times 4, and a squared, which I could break down further into 16 times a squared. For 3, let's just make it easy. M to the 3rd times the 4th, because I share it with both. And then n to the 2nd times 4, which would be m to the 12th, n to the 8th. And for 4, so now I have to share the 3. I don't share the 3 with the 3. You have to look at this as 3 to the 1st power, because we know when it doesn't have a power, that implies that it's 3 to the 1st. So we would do 3 times 1, which is 3 to the 3rd, and then 3 times 3, which is x to the 9th. All right, so now let's look at what happens when we're dividing exponents with the same base. So when you break it down, you have x times x times x times x times x over x times x times x. Well, I know that if I were to have 2 times 2 over 2, that it would give me 4 over 2, which is 2. So when I have this, I can simplify by crossing out anything on top that's the same on bottom. Okay, this works with multiplication only. So here, I have 1, 2, 1, 2, 1, 2. So I'm left with x squared. So how can you use x to the 5th over x to the 3rd to get x squared? If you notice that you can do 5 minus 3 and get the 2, you'd be correct. So I have x to the 5th over x to the 3rd. And that tells me that I can keep my base and subtract my exponents. Okay, again, so the law tells us that for any real number a, where a to the first is not 0, and all integers m and n, a to the m over a to the n is equal to a to the m minus n. So let's try these. So I have a times a times a times a times a. So 1, 2, 3, 4, 5, 6. We're going to have to move this off to the side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 over 1, 2, 3, 4, 5, 6, 7. So cancel each other out. So cross off all the times a's that cancel each other out. And we're left with a to the 4th. So now here we have to break